This is a Math 1 lesson summary video for the lesson titled Rocking the Residuals. This is a develop understanding task. The purpose of this lesson is to use residual plots to analyze the strength of linear model for data. The correlation coefficient is not the only tool that statisticians use to analyze whether or not a line is a good model for the data. They also consider the residuals, which is to look at the difference between the observed value, the data, and the predicted value, the y value on the regression line. This sounds a little complicated, but it's not really. The residuals are just a way of thinking about how far the actual data is from the regression line. So let's start with some data. So in this video, I'm going to explain residuals and how to find them, and then I'm going to show you how to use Desmos to calculate the residuals with technology. So starting off, I have my scatter plot, and I'm going to use Desmos, or my graphing calculator, to calculate a line of regression. So in this case, the equation for the linear regression line is 3x plus 6. Next, I'm going to take a look at the points on the regression line. So here, I have 9, so I'm going to fill in my table. So 1, 9 is the point on the line. I have 12, 3, 15, 4, 18, 5, 21, and 6, 24. Now when finding residuals, we're finding how far away each point is from the line. So the observed point that is originally graphed, this point 110, how far away is it from the line? So it is 1 unit above the line. So 10 minus 9 is 1. I go over to my second point, and that one is also 1 unit above the line. 13 minus 12 is 1. My third point is below the line, 8 units. 7 minus 15 was negative 8. Here I'm above the line, 4 points above the line. I'll measure this distance, which is 7 points above the line, 7 units above the line. And here I am 5 units below the line. So just to recap so far, I have my original data, and then I have the y values from my line of regression. And then I measured how far away each data point was from the line of regression. So these are my residuals, how far away my observed value is from the predicted value of my linear regression line. So next I'm going to make a residual plot. I'm going to use the same x values and then these differences, these distances, and I plot those like a scatter plot. So this point right here represents x being 1 and the output here, y being 1. And then 2, 1, 3, negative 8, 4, 4, 5, 7, and 6, negative 5. Another thing to note is since we did use a linear regression model using technology to get our line of best fit, when you calculate these residuals, the sum of the residuals, add all these numbers up, is 0. All right, let's take a look at Desmos. So here I have the same data, looking at this from beginning to end with Desmos. Once I've entered the data, I'll type in the command for the linear regression line. And right here, I have this little button that says Residuals E1 Plot. And I can click that, and it automatically creates my residual plot. It also tells me how far away my data value is from the line. So this 110 was 1 unit above the line. The 0.37 was 8 units below the line. So positive values mean that those are my points that are above the line, and negative values means that those are the points below the line. So now I have 2 different ways that I can assess the fit of my line. I can look at the residual plot, and I can look at the correlation coefficient. So when trying to determine if a linear function is a good fit for the data, look for a residual plot with randomly placed points. You want to avoid patterns. So if we're looking at these two examples, this one clearly has a pattern where the data increases and then goes back and decreases. That means that the linear regression line is not an appropriate model for that data. This one, however, even though that does have an outlier, the data values are pretty randomly placed about the x-axis. Because of that, this is telling us that that linear model was a good fit for the data. All right, that's it for this video. Thank you for watching.